Hello, everybody. Welcome back to video 21 in this series. I am teaching a summer camp to high schoolers later this summer and was just giving some of my lectures a practice run. I shouldn't really call them lectures. I am making this up as I go along, and I'm going to make it up as I go along in the camp too. Just getting the general idea. My notes have things like make a landscape, have a character move, then add a water shader. We're just now up to the water shader. Started that in the last video. So it's a very loose plan, but I still want to have a plan when I go in there. Just be ready to adapt to the particular students in there. Because the only thing I know going in advance is that these are high schoolers that are very, very interested in potentially pursuing game development careers. So that's why I wanted to go into at least get started in shaders instead of just materials and show them how to code it because we can do a lot more interesting things in our with our game graphics if we code the materials basically, and that's what shaders are for. So in the previous video, we created our spatial shader. Um, Godot uses one based on OpenGL, which is pretty much the standard. Things that use something other than OpenGL, it whatever they use will be roughly based on OpenGL. It's not an official standard anywhere, but anybody making a shader is not going to go too far from OpenGL. Uh, you'll notice it is a language with curly braces and semicolons, so remember your semicolons each line. And so far, we created a variable for our watercolor and then said use a color picker for that because this keyword here, uniform, is what makes that show up over in our inspector panel so we can do stuff. So got a color for our water, but we can do better than that. Water should have like waves going. So I want to create a couple waves. Again, I want to be able to control them from the inspector so I can make adjustments while debugging the game and stuff. So I want a couple vector twos. And um, we're in making a 3D game, but for the waves on the water, vector 2 will be enough. And the type of data is it's going to be a sampler 2D. So it's the surface of the water. So we just need that 2D sample to put on there. And this is going to be our noise texture. Oh wait, I'm getting ahead of myself. We're not to the noise texture yet. Let's make the waves. Uniform vector. Sorry, a vector 2, and I'll call it wave 1 and wave 2. And that's going to be a new vector 2. Um, so it'll be in the inspector panel, but I want to give it a default value. So we need an X and a Y. And what matters here is one of our waves, hence the reason it's wave 1. One of our waves, I'll just copy this and paste that in there, make this wave 2. Actually, I'll call it wave Y and wave X. And that'll work way better for the explanation I was trying to get into there. One of our waves needs to have something in the Y, so maybe 3.1, 0.0. Oops, not 0.0. And the other one is going to be only an X, or 1.3. And they do need to be drastically different. So in order to get them as waves, think about the bumps and uh, let me draw a picture. Okay, I'll draw a picture here because I was thinking of uh, well, there are lots of tutorials that could just show you how to code it, right? We could jump through that and um, this is about 20, 25 lines of code, so we could do that in probably 5 minutes. Uh, these videos and the students that I'm preparing for here are, I want to go over the concepts and, well, we saw the keywords to go search for those tutorials, so I want to make sure and go over the concepts. So I'm going to grab a wave here, and the reason we need two waves, I guess wave 1 and 2 would have been good. So we have the idea of a wave, and one of them I set in uh, is, I think I put 3.10 for that wave. and the other one had 0, 3.1 or 1.3. So one of the waves is nice and big, and the other one is a lot smaller. Um, I'll draw it like that. So then when we take the superposition of those waves, the crest on these waves will add together, and the troughs on one wave will subtract from another one. So like those two spots would add up to a little bump. Then this one kind of doesn't go up so much, and up and down, and then here it kind of goes down, then back up, and we add those two waves. We want to add those two waves together and get a superposition of the wave we actually want. So that's why there's two of them. And then we will have them moving at different speeds so that it makes a very natural looking thing. All right. Thought I'd draw a picture of that because this one's about the concepts in game development, uh, not just a pure tutorial of write this code and stop after showing you what code to write. So let's go back over there and write the code for that now. So we have our big wave and small wave. I guess I could call them that because it's not really one's going in the X direction, one's going in the Y direction. They're gonna overlap with each other, and we'll do it across different times. And you'll see over in the inspector panel now, we have controls to fine tune, figure out what some good numbers are for those. And then the thing I tried to jump ahead and do. Um, we don't want them to be perfectly smooth. On top of that superposition, we're also going to put a noise texture. And actually, I want to put two noise textures for the same reason. So I'm going to, again, ask for a uniform, vector 2. This is the one I tried to type a moment ago, sampler 2D. So we'll set this up as noise 1, and uniform vec2 sampler 2D. Why is the predictive text not showing up? Noise 2. Did I spell something wrong? Whoops. I don't see a typo when I look at it. Let me copy this line that isn't marked and paste that in there. Well, why is that going on? At line 8, expected an identifier. Oh, sorry. I have no idea why I typed vector 2 there. Sampler 2D is the identifier. Sorry, got a little confused there. I am kind of half making this up as I go along. Uh, I have no idea why I typed vector 2 there. Must have been thinking about something else. But that gave us these noise transitions. Uh, so let's set some noise in these. And what we're going to do over here in the inspector, there, click on the thing, and down at the bottom you'll see new noise texture. And if we click on that again, then we'll get a bunch of options for it. In particular, down at the bottom of the noise, choose a new fast noise, and then click on that, and choose some of the what type of noise we have. You can see the little preview. It's going to create this type of noise, and when we have two different patterns that we can lay on top of each other, the superposition between them will make uh, a nice wave. And then we'll mix that with those vector 2s, so that things kind of look nicely. Maybe Perlin, and under fractal, you can change this ridge to ping pong. Actually, ridge there kind of looks like water. I'll go with ping pong. And choose a couple of those. And we have the same thing for the other noise texture. So click on the empty spot, new noise texture 2D. Uh, oh, not color ramp. The new fast noise. And when we click on that, we can choose the texture that's going to overlay with this, and they'll kind of mix together. These the interacting with these two mixing together. What's value? Maybe that'll look good. Um, and ridge this time. Those two noises might mix together to make some a good wave looking thing. So once you get those set up, and again, I'm just picked a couple. Hopefully, it was clear that I was just picking them at random, kind of scrolling back and forth and trying to visualize in my head a little bit what those would look like if they were raised up. If the first one is raised up this far and the second one is raised up this far, and then we lay them on top of each other, what would they look like? So now we need to do that. So our wave X and wave Y, those are actually our time scales. In that picture I drew, one of them was stretched out really far, and the other one was the wave crest were close together. That was to represent time. So let's create a new vector 2 here in our fragment function so it applies to the whole thing. So a new vector 2, I'll call it time y, and that's going to be this constant time that's going to pull straight from our game engine. It's going to get a time value from that, and we can multiply that by wave y. Um, and then I'm going to multiply that by just some small number, 0.025. And then this is going to be, this number is kind of like delta in the earlier one. We could hone in on a different number. I'm just going to put a really small number for now. But think about delta in that script we did earlier on a character. The amount of time each frame takes to pass. We don't want it to exactly match our frame rate, so something longer than our frame rate. So uh, I think I think I'm set for 60 frames per second, which would be 16.7 milliseconds. So I went with 25 milliseconds is the logic there of what was going on. So another vector 2, I'll call this one time x, and that's going to be that time value that we get from our GPU, that we get from our game engine. Multiply that by that other wave so that we're getting different things, and then that small value, same small value. Oh, whoops. Don't forget semicolons. Get used to doing the GD script, and it's easy to forget semicolons when we get down to our shaders. And now we can turn that into a vector 3 normal. So what a normal is normal is the direction straight out from any surface we're on. So currently, in our flat plane, straight out from the surface is straight up. Every every face making up that plane has the same straight out. But if we change it with the superposition of these waves we've just created, uh, it'll still be a flat plane, but the light will reflect off of it as if there's this constantly changing, uh, lots of little faces that are constantly changing. So we'll end up with lots of different straight out, which changes how the light reflects off of it. And that's how this is going to kind of how this works. So there's this built-in method we can use, mix, and these I'm just going to kind of type in. And what we want to mix is we want to create a texture out of this noise. So we'll use the noise one and use the UV, which is actually the XY. So if I stretch back out to see this, UV, where, am I looking at the wrong thing over here? In the water shader, collapse the resource. Where'd my little thing go? Oh, yeah, I know. Because there's an error showing, so nothing's showing up over there. Um, if I comment that out, there we go. So we have these noise textures, um, and then that's depending on how white that grayscale, it's going to come across as a different angle, which will cause light to reflect differently. And UV is actually the XY components, since um, it's the second option, right? Letters near the end of the alphabet. The U axis is like the X axis, and the V axis is like the Y axis for this little plane here. So whenever you see UV in these things, that means it's a secondary source. So they didn't want to use XY because XY are on the used on our primary objects. So they went with the next best letters. So, oh yeah, and like you saw there, if there's an error, then it can't load things in the inspector panel. And I want to change that though by one of the time factors, by that time Y we just created. So I want to mix that, and from that I'm going to pull RGB, the RGB value, and then create another texture with the noise too. And again, it has UV coordinates instead of XY because it's a secondary object, not a primary object, plus that time X. Get a semicolon and oh, dot RGB. And don't forget to put dot RGB because it needs that to pull the grayscale. Oh, one more number here. A small number is sort of a percentage. So let's say 70%, so that we do see a good solid effect from it. Which we don't see it yet, but if we come in here and now create a normal map, notice just like our color, there's this all caps constant. So the normal map for this material we're making will assign that normal to it. We can see it over here. I was expecting it to kind of show up in the preview there. It's kind of hard to see. Maybe if we run the game. Over here, we'll kind of see some waves. Um, those might be a bit spread out from the random pattern. So come down here. Let me do this. Let me go back to the sun and change back to a really fast passage of time so that we'll see the sunlight change across it. And there we go. When the sun's shining on it, we can kind of see some waves in the water. Maybe not the best texture. You'll want to come around and play with those textures. Was trying to explain what they're doing. Notice we don't see anything if it's not in direct light. When it's in the shadows, we don't get much. But you can come in here and try different ones. So if we come back to that Mesh Instance 3D, which right now our character can just kind of walk into that water. So maybe create that a tri-mesh static. So now there's a collider on top of it. Our character will sit on top of it. And we can try different noises. So down here under fast noise, if we switch this to ridged, I like the ping pong better. Keep that one a ping pong, so maybe this one needs changed. Right now it's a value, so what if we switch that to cellular? That might be better. It's a start. This video is almost 20 minutes long. You'll want to go in there and play around with those values. Play around, try the different noise options. You can look at the preview here. You can see it's not quite the same. Maybe I'll set them both for the same thing. Maybe what if this one was also Perlin? That looks like smaller waves in the preview. But this video is getting long. You just want to go in there and play around with different numbers, try different heights on those vectors we gave. I think I put 3.1 and 1.3. Try different numbers, see what you get, but notice how we have a very dynamic material now. That's what shaders are for. Gives us a lot more control over our material. Play around with different settings on those. Which all ones was it? So it was these values. So maybe cut that down to 2 and 0.5. Let's see what a smaller one does. We can kind of see the preview there. Run it, and I will leave it to you to try different values and change things till you find one that looks kind of nice. Different shades of blue, and all we really need to do to make a nice water editor is set up some time wave components that will create a nice superposition when we put them together, and create a couple noise textures that will also make a nice superposition when we put them together, and then mix all that together, give it some sort of mix. This value is how much the first one shows. So right now it's showing 70% of the first one. I don't want to do a 50-50 mix, but you could try that. Do a 50-50 mix between them. We'll start to get big shadow areas if we do that too much. Looks like it's heading that direction, but I'll leave it to you to kind of play around with that. Also seems to be moving kind of fast, so this number right here, to slow it down, you would put a bigger number here. Definitely something to play around with. Try changing those values, see what you can do. That's the basic idea on how to make a water shape. And yeah, play around with it. Try to find a nice one. Hopefully that makes sense for shaders. Instead of just setting up a material and going with it like we did this green color for our landscape, we can have a lot more control over it. Hopefully you're probably quickly realizing that we could also make our ground look a lot better by doing basically the same thing here, but removing the time component so that we just have a big bumpy surface that looks like grass and weeds and things like that. And just don't move it like we do the water waves. But something to play around with it. You'll want to go in there and try things, see what you can get to work. That's all I want to do for the quick introduction to shaders. There's going to be more shaders. I'm going to do a shader for the sky and probably come back and do some editing. This is nowhere near a final draft. But hopefully some of y'all may have found that useful and hopefully understand a little bit about what's going on with shaders now. I'll see you in the next video.